Welcome to Adventures in DevOps. My name is Scott Nixon, and with me this week are Charles Wood and Oleg Chuninkin. Say hello, everybody.
Yeah, hello.
Hey.
Awesome.
Hey, folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there, The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
So, all right. So, Oleg, you are the CTO of Kublr, and you're here to talk about Kubernetes and lots of all the fun things around infrastructure abstraction. And I'll let you just kind of introduce yourself. And if Chuck, if you want to introduce yourself as well, go ahead.
Okay. Yeah. Thank you. Yes. As you correctly pointed, I'm CTO at Kublr. Kublr is a company that develops a enterprise Kubernetes management solution, and essentially it's built around an idea that Kubernetes won sort of container orchestration war for a reason. So it's a great abstraction layer that separates responsibilities between operations teams and developers teams, and provides so much more than just container orchestration. So I suppose that's what we're going to talk today.
Cool.
Nice.
Chuck, if you'd like to introduce yourself.
Yeah, I'm Charles Max Wood. I'm the CEO of devchat.tv, which really means that I host as many shows as I want to and then tell everybody else what to do. No, I reach out to people all the time to be on the shows, to host the shows. We actually have some host openings on some of the shows. If you're interested, just reach out to me. I'm also working on maxcoders.io, which is going to be a platform for developers who want to build successful careers and meaningful lives. So if you're trying to find those skills that they don't talk about on the other course platforms, usually we call them soft skills, but there's more to it than that. And, some of them are just life skills in general. That's what I'm focused on. So.
Awesome. All right, Oleg, I guess we can, start with the topic today about infrastructure abstraction. I know you have some great points that you wanted to share that you have organized, so I'll let you just take the floor.
Yeah. So, the idea of this topic came to me essentially originally when we tried to explain the place of Kubernetes in the ecosystem, and especially in the enterprise, because we all know there are a lot of solutions currently on the market related to Kubernetes. Pretty much every vendor, every company established in IT built something around Kubernetes. Cloud vendors, orchestration solutions like Mesos, Docker build Kubernetes into their solutions, and everyone has a little bit different angle on what Kubernetes is in their solution or product, and we tried to think about what would be the most productive way of thinking about Kubernetes when you are essentially a CTO or CIO of a large organization or a mid-sized organization, small organization, that thinking a little bit ahead and thinking about what container orchestration can bring them and what to prepare for. So, and what we thought was a productive way of planning for container orchestration platform deployment in an organization is, essentially trying to combine cloud native benefits and still stay within the limits that your enterprise sort of requirements and your enterprise application nature puts on your stack. So one of the way of thinking about Kubernetes and container orchestration would be to look at it as an infrastructure abstraction layer. So essentially, you as an enterprise want to reap the benefits of cloud migration. At the same time, you want to keep flexible, to be able to use infrastructure provided by different vendors. At the same time, you don't want to rebuild your applications every time when you want to use another service from another cloud provider, or you want to migrate from Amazon to Azure. And at the same time, you don't want to adjust too much your governance and operational sort of components and harness to every cloud vendor or infrastructure vendor stack that you start using. You want to stay open, and there is nothing better than Kubernetes for that as a basis for a solution or architecture like that, because you can rely, you can essentially run Kubernetes on pretty much any infrastructure. You can run pretty much any managed or middleware service on top of Kubernetes. And by middleware service, I mean services that you are nowadays used to see as managed services in cloud providers stacks, like databases, managed databases, for example, or managed file storage systems, or various ingress traffic management systems, etc., or let's say messaging or ESB systems. So all that can run on top of Kubernetes, and what's even better, Kubernetes solves a number of operational concerns around managing those services. So it becomes
Can I
feasible.
Stop you for a minute? Well,
oh, sure. I'm sorry.
No, it's all good. It's just I'm trying to kind of break the ideas apart, if that makes sense. And I feel like we've gotten like 3 or 4 here, and I want to make sure that we understand them right, and then we can talk through them on the show, and that way, people can get their heads around it. So, I mean, what it sounds like, you're essentially, you're advocating for Kubernetes, which makes sense. I mean, you can, like you said, you can run it on pretty much any Linux machine. And you also mentioned that you don't want to have to change it up too much in order to run it on one cloud platform versus another. But what it almost sounds like you're advocating is that developers run Kubernetes locally or in some kind of local, on some local server, and then essentially orchestrate their architecture so that it, you can see what it does or what it will do in production. Is that a summary, and how does that actually work, if that is?
Yeah, you're right. So this is one of the ideas. So first of all, Kubernetes is a great portability layer for developers. If you develop your application for Kubernetes, you can then run it pretty much anywhere, as long as you don't tie yourself too much to cloud provider specific managed services. So you have, or we have, very, very, very lightweight ways of running Kubernetes on developer's machine for dev environment, like Kind, for example, Kubernetes and Docker. So you can just develop for this. So it is not more resource hungry than just your average Docker container, and then deploy the package you developed onto Kubernetes on Azure, onto Kubernetes on AWS, or onto Kubernetes running in your own data center. So that's one of the ideas. So in a sense, Kubernetes hides from you differences in the infrastructure.
Okay. So if I decide, okay, well, this makes sense, right? I'm going to set things up so that it orchestrates through Kubernetes, and so I'm going to set up a machine that runs it. What do you recommend then to run it in a lightweight way? Because I'm trying to imagine running it on my like my work laptop or my work desktop, and I'm wondering if it even has enough resources to run. If I have 4, 5, 6 services all running in different containers.
In some cases, it won't be enough, right? You will have to have a separate dev environment, probably in a cloud, if your application is that heavy, essentially, even in development mode. Although very often more often than not, I would say you could split it into components that are lightweight enough to run within a single machine. And so what also is good with Kubernetes is that you can also, if it's designed in a cloud native way, when all your dependencies can also be represented as containers, you can pretty much have the whole development environment running on your laptop. Just think about replacing S3 with Minio, which is lightweight enough to run on a small machine even. Think about, running a Ceph for file storage if for some reason your application relies on dynamic volume allocation and requires file system, or just use your local disk for file storage. You can run MySQL for database. Yeah, I don't think that resources is a problem in most cases for dev environment. But if it is, you can just bring up a Kubernetes cluster in AWS and develop against that if you need more resources. But what's more important from portability standpoint is that you can bring the same Kubernetes cluster in Azure then. And so if for some reason your IT strategy changed for your company and you want to use Azure instead of Amazon, for example, because Amazon becomes too prominent in retail business, or if for some reason you want to put parts of your application into data center because some of the governance requirements or compliance requirements changed, moving between different Kubernetes clusters in different environments is much easier than moving between completely different infrastructures.
Right. One thing that I'm wondering there, because one thing that I found is, for example, if I'm using, let's say, Linux distributions, right? If I specialize on one, I tend to get mileage out of it, right? And a lot of the clusters out there, like Google Cloud Platform or AWS or Azure, they have their quirks. And if you build to their quirks, then moving, you have to basically unwind that, right? And move out to kind of an agnostic standard, or add in whatever you're going to need to move it to AWS or GCP or Oracle Cloud or something like that. But how often does that happen, right? Is this a concern that I really need to worry about? Or is this something that, if I wind up having to move off of Azure or off of AWS, I'll just take the hit at the time? When is it worth the trade-off to go vanilla Kubernetes? Or is there not much of a trade-off to do that?
That's actually a great point. So it's rarely worth it. But I'll try to turn it around a little bit, because it's less about taking a hit when you migrate. It's more about being able to support multiple environments at the same time. So even if you are in a single cloud, your development and debugging may be a bit more productive if you can run locally. And that's already different environments. But in most cases, companies, especially larger enterprises, have a lot of legacy software and environments that are not going to go away anytime soon, like mainframes running in the data centers, accompanied with more modern hardware. And for some of them, they'll stay like that because they're not going to migrate overnight. It requires time and money. Others will stay like that because it's governance, because they just are not allowed to run anything in the cloud, but they still want to be as agile as you could be in the cloud using cloud native architectures. And development teams more and more often put pressure on IT management, on IT operations teams to migrate to newer technologies, to this modern, fashionable cloud native stack.
That makes sense. We've been recording Ruby Rogue since 2011, and we've talked to a lot of people who have had a really deep influence, not only on the programming community, but also on the Ruby community. And as we've talked to these people, it's become apparent to me that we talk a lot about the things that make them interesting that they've done, but we don't really get into how they got into programming or how they came up in their career, how they got to be the person who invented whatever library or technique that they came on the show to talk about. And so I put together a show where we actually highlight these things. We talk to them about how they got into programming. We talk to them about how they got into Ruby, maybe how they got into Rails. We get a little bit deep into what makes them tick and why they are the way they are. And then we talk about what they're working on. We talk about the things that make them well known or make them interesting. And a lot of times it's the stuff that goes beyond the code that really makes these people tick and makes them the kind of people that we want to hear about. And so I put together a show called My Ruby Story. You can find it at myrubystory.com. And it's where I interview these people and just get the stories of these people and how they came into programming. So if you want to hear inspirational stories or get ideas on how you can actually advance your career, then go check it out at myrubystory.com. Scott, you have a lot more experience with a lot of this than I do. Does this line up with your experience or?
So one of the questions I was specifically thinking about was, and I've not experienced this directly around Kubernetes, but like I've experienced where I've had clients that it was almost like a kind of pillar requirement that they wanted to be kind of possibly be cloud independent, meaning that they did not want to like use, say an AWS service that is specific to AWS. So they wanted to be able to just move things around. And it sounds kind of like, Oleg, that a lot of the things that you're saying, I don't know if you're experiencing this as well, that this is driving a lot of the core requirements that maybe is coming down from like top management, that people need the ability to kind of move between these different environments really easily. Is that, can you kind of address that a little bit? I'm curious.
Yes. I think this push comes from two directions. Actually, you are right. So on one hand, developers want to be more agile, more convenient tools, and operations want to be able to deliver quicker and more reliably. Management at the same time wants safety and security, and that's several vectors that come together, and sometimes seemingly they conflict because those enterprise requirements. And when you look at cloud native stack and how cloud native architectures are built, it seems that it is not compatible with those enterprise sort of very hard, inflexible framework. So at the same time, if you can build your sort of Kubernetes platform into that framework and make sure that with governance and operational requirements are built around Kubernetes as container orchestration and management, your developers can deal with it essentially in almost the same way as they are used to deal with Kubernetes and container orchestration in more essentially allowing and open, less restrictive environments. So they can have the same flexibility and agility. Okay.
All right. Are there some other points that you wanted to, in particular, like discuss? I know we kind of like started diving in with questions, and it may have gotten you a little off track. So.
Yeah. So one thing that I wanted to maybe emphasize is that we focused a little bit more on portability that Kubernetes brings. But another thing related to that is that not only your applications, custom applications that you build, mission critical business containers, become more portable. But what's interesting, you can use that to provide reliable and portable middleware services. And Minio is very simple example. So like you don't have S3 API in Azure, but you can host it yourself and using Minio running on top of Kubernetes. And with Kubernetes, it becomes much more feasible to do so. It's still an overhead. It's still, I would recommend, again, more often than not to use a managed service if you can. But sometimes in a short-term perspective, instead of rewriting your application, you might be better off running Minio on Azure or in your data center to replace S3, for example. Another example is...
What was that solution that you were recommending we run?
Minio, it's an open source, essentially distributed file storage project. Right. They provide S3 API, they provide replication, essentially very, very similar set of capabilities as S3. Okay. Another example is Rook and Ceph. So Ceph, is an open source distributed file storage system supported, led by Red Hat, if I'm not mistaken. And Rook is a Kubernetes operator that manages Ceph clusters running on Kubernetes. And again, so if you can afford or if you can use a managed file storage system, you are better off doing that. But if you have particular requirements that this storage system cannot implement, Ceph and Rook make it much more feasible running, again, portable cloud native storage solution that does not depend on any specific cloud vendor. And with Ceph, you can do things like, for example, same EBS or EFS on Amazon cannot do, or any other cloud-specific storage system cannot do, like running Ceph clusters that replicate data from region to region, or even from cloud to cloud, or from cloud to your data center, or back for failovers, for backups, for data access optimization, for example. So some things that otherwise you would have to rely on some essentially vendors that provide you with closed source solution, which will only work with that specific vendor.
Okay, gotcha. I'm curious. So, a lot of these open source tools that are, that you kind of mentioned, like, I guess one of the challenges is that, like maybe you have trouble getting support for them, or you have trouble, maybe you encounter some kind of bug, or they have limited features, those types of things. And, like, is there good avenues for people to get help, or to, is that something that your organization gets involved in at all, or are you guys mostly just providing software?
Yeah, so that's one concern that you always need to take into account. That's absolutely true. Again, and I'll repeat it again. So if you can use a managed service, use a managed service.
Yeah.
But if your requirements are such that managed service cannot provide some of them, Kubernetes and container orchestration makes it much more feasible to build such a solution and maintain it. And at the same time, yes, there are, of course, vendors that provide solutions like that, either support for open source solution like Ceph. You can have it with Red Hat, or I'm pretty sure there are a number of other organizations that can support it. Or there are vendors that build solutions in the same sort of vein and philosophy, like, for example, cloud native storage systems are well represented by Portworx. If you're looking for commercial solution, it's again a startup which built cloud native, but yeah, it's well established, mature enough startup which built a cloud native storage product that can do essentially the same as same set of functionality as Ceph and Rook and anything you can expect from mature cloud-native storage system. It runs on top of Kubernetes, and again, in a sense, you're still running some vendor-supported solution, but it does not depend on cloud infrastructure now. So you are free at least from cloud vendors in a sense. Other examples may be Yugabyte or Mongo. Mongo, you can have both free essentially solution run by yourself. You can have support for Mongo. It's plenty out there, or you can just work with Mongo and buy their commercial product and run it on top of Kubernetes. Or Yugabyte is another example like that.
Okay.
Also distributed database.
Yeah, you made kind of reference into the summary about a layered architectural approach, helping kind of future-proof an organization within their Kubernetes strategy. And could you kind of explain that a little more? I'm kind of interested to learn more about what your thoughts are.
Mm-hmm. Well, yeah, it's essentially grows out of comparing different approaches to how Kubernetes-based solution is built. So essentially, one way of building Kubernetes solution, and that's what we are trying to pursue, Kublr, is to try to build, let me call it operational harness around Kubernetes, essentially a number of tools, components, interface, control center for Kubernetes, but make sure that Kubernetes it deploys is upstream conformant compliant Kubernetes cluster, and stop where essentially we go sort of beyond what Kubernetes can provide. So when we are talking about, for example, cloud native storage solution, it is not Kubernetes. There are a number of solutions that are already available and can provide this functionality. So it's not sort of first step for us, although at some point we are adding also sort of features that can be deployed separately on top of Kubernetes clusters that provide this or that functionality. Another approach is to build tightly integrated stack, which may have Kubernetes inside as an engine, which may be based on Kubernetes, but modifies essentially some of the Kubernetes concepts significantly enough so that it can be considered already not even a distribution, but somewhat modified version of Kubernetes. And this is what we can see, for example, in OpenShift. And this also makes sense from one perspective because OpenShift started as a PaaS. Essentially, OpenShift 1 was a platform as a service with proprietary APIs and formats and packages, etc. And at some point, Red Hat realized that Kubernetes provides significant set of features implemented in OpenShift, and they essentially replaced core and engine in OpenShift PaaS with Kubernetes. So now what OpenShift is, it is a compatible to some degree Kubernetes solution, which provides a lot of opinionated, essentially integrated features that allow you to manage application lifecycle. And that's what OpenShift is focused on. And that's great for quick start because you don't have to separately learn Kubernetes and then decide which CI/CD tools you want to run on top of Kubernetes and then build CI/CD pipelines for your applications because you already have it as a part of OpenShift. You just run OpenShift and you have the right way of building, deploying, and running application on top of that. Downside of this approach is that, of course, at some point, it may start limiting you. And at some point, some of the development groups may be more comfortable with other tools that they want to use for their application development and delivery.
Back when functional programming was making its resurgence, I found it really interesting that a lot of people were moving over there, and it almost felt like it was on hype, and I didn't really understand the power of functional programming until I learned Elixir. Elixir is a functional programming language. It's built on the Erlang virtual machine, and it really does some interesting things and makes you build apps in a different way. But what's really fascinating about it is the speed of the applications, the ability to distribute work easily, and just how it manages the functional programming and all of the nice things about it so that you don't have to worry about side effects and a lot of the other things that come out of functional programming. Plus, pattern matching in Elixir is a killer feature. If you're looking for a new language that you want to learn that is going to make a difference for you and give you the opportunity to challenge some of your thinking and find a new way of doing it, Elixir is a great way to go. And we have a podcast now on Elixir called Elixir Mix, and you can find that at elixirmix.com.
So, and in that sense, to your original question, so architectural layering helps you, us at least, keep this openness and make sure that we don't stand in the way of Kubernetes and we don't modify it. So essentially, when you plan container orchestration platform for your enterprise, if you think just in terms of layer separation, let Kubernetes do what it does best, container orchestration, and build on top of that. Put CI/CD component, which runs on top of that, put databases or data storage components, put your applications on top of Kubernetes. Don't mix them up. So that's our preferred approach.
And you're saying that OpenShift does kind of mix those two up and they kind of maybe get in there a little too tightly. Is that what you're saying?
That's my impression. Again, I'm not saying that it's that one way is always best or better than another.
Totally.
But OpenShift is definitely much more about application lifecycle management and application delivery and CI/CD than Kubernetes by itself.
Gotcha. They've added they've kind of tightly integrated the CI/CD into the Kubernetes stuff. And okay, I got you. I'm following you. Yeah, I don't have any experience with OpenShift. So.
And again, OpenShift is just one of examples. As I said, pretty much every Kubernetes solution out there has its own angle and focus. So, and again, it's difficult to say, impossible, and probably won't be possible to say whether there is one right way. So,
yeah. So one thing that I'm wondering about is in our prep notes, you said that you're going to discuss how a layered architectural approach will future-proof an organization's Kubernetes strategy. And I'm wondering, what do you mean by a layered architectural approach?
Yeah, so it kind of helps us bring everything together. So by layered, I mean you have infrastructure layer. That's where you get your sort of raw resources, compute, network, storage, and that may be your data center, that may be multiple data center origins in one or several clouds. Treat them as raw resources. That's compute, that's storage, that's network. Now, on top of that, you have a layer of container orchestration. And so container engine and orchestrator and Kubernetes is great at that. Again, keep it, run it on top of your different infrastructure providers. Keep it sort of separate from higher layers that are your CI/CD, your potential storage, your databases, messaging, and then again, next layer is your essentially custom application, something that you build yourself and you run for yourself. That because each layer is separate, not tightly integrated, at least conceptually, into any other, they can develop and get new capabilities over time relatively independently. So your Kubernetes follows open source Kubernetes development. Today it's 1.12, tomorrow it's 1.13, gets new capabilities over time, but higher level, being able to run on top of Kubernetes. Any Kubernetes can develop at its own pace, essentially.
Are there some specific challenges that you think people should know about when you're trying to go from, say, one platform to the next? Even if you're running multiple at the same time. I'm just, if you start on AWS and want to move to GCP, how does, are there some things that you have to be concerned about or look at?
Yeah. Well, there are lots of them. And again, so from my perspective, in my experience, keeping, concerns and layers separate allows you to eat this elephant piece by piece, rather than have all those problems at once. Instead of migrating from, for example, Google Kubernetes engine, GKE, or not migrating, but trying to run your application on one hand on GKE, on the other hand on Kubernetes built from scratch, running in your data center, which may differ in versions, which may differ in settings, features enabled, etc. You can solve essentially problems of incompatibility first for Kubernetes layer. So make sure that you have a Kubernetes deployment that is more or less in uniform way can be deployed on top of compute resources in the Google Cloud, in your data center, in your AWS. And then having already some of the differences eliminated by this Kubernetes abstraction layer, you can develop or move applications and higher level services essentially with less with fewer problems essentially. But yeah, specific issues, of course, can include differences in how network works, how different overlay providers can work, how storage behaves, etc., etc. And of course, SLAs and
But Kublr's meant to make it easy or to assist in making this process between those a lot easier, right?
So my idea of Kublr is exactly to focus on these two layers, infrastructure and Kubernetes, and deliver some sort of uniform Kubernetes deployment on top of wide set of infrastructures, accompanied with a number of operational capabilities, again, working in a uniform way across different environments. It's like log collection, metrics collection, alerting, integration with identity management, so things like that.
Yeah, gotcha. Well, this has been really, really interesting and fascinating. Is there any other kind of like wrap up points that you'd like to make before we kind of move on to picks?
Well, I'm kind of curious real quick with Kublr. Is there a place people can go check it out?
Oh, yes, you can. Absolutely. That's a good point. On our website, it's kublr.com. I think
just drop it in the chat and we will put it into the show notes.
Yes. So on our website, you can just get information about how to run Kublr and container on your machine, and it will give you overview and demo of what Kublr can do. You can, from that container, you essentially can deploy full-blown Kublr installation in any of the cloud environments you own or on-prem, and play with that without limitations for non-production use, essentially.
Okay, wonderful. Well, we also always like to kind of wrap up every episode by kind of just giving our audience like a suggested pick. So, everybody can, I'll go ahead and go first. And so this is probably a really popular book. I love to make book recommendations, but I've really enjoyed Sapiens. I've had to keep checking it out from the library as it's a long book and it's taken me a long time to get through it. And so that I think that's a really great book that just kind of covers a lot of like, the progress of humanity. And so it just gives like, it's funny because I find it really hard to like give it like a clear explanation of what actually it is, because it's just covering like, like the growth of humans and technology. And I feel like it's kind of going back and forth all the time. It was super.
Is it Harari?
I'm sorry?
Is it Harari? The author? Harari?
Yeah.
Mm-hmm.
Yeah. And I just think it's a fantastic book. The other recommendation I'm going to make, Nell often makes, she's made a lot of like note-taking apps. I've been a big fan of using Ulysses, and it's something that, I can write it in Markdown. It's really easy to export. It syncs really well. I think it's really affordable as well. And so those are my two picks, Ulysses and Sapiens. So, and Chuck, do you want to do some picks?
Yeah, absolutely. It's funny because, both of those sound really, really interesting. I'm like, I'm going to pick trying out whatever Scott just said. It's kind of been a long week here. Lots going on. And I've kind of picked this on a few shows this week, but so it's kind of been a long week. There's been a lot going on. So I'm going to shout out a few things. One is that we've had a few spots on some of the shows that we've been trying to fill, including this one actually for a little bit. See if we can get a few more hosts, get a little bit more conversation and a little less interview into the shows. So if you're interested in being on any of the shows, that would be great. I currently have openings on Adventures in DevOps, Adventures in .NET, Adventures in Blockchain, Sustain Our Software, JavaScript Jabber. I think I'm going to have full. I think I have a spot on Ruby Rogues and Views on Vue. I have a few spots open. So and I think I had two people that got busy and had to pull out of React Roundup too a few weeks ago. So anyway, all of that to say, the shows are still going, and we have solid people on them. But I like having a conversation of a handful of people for the episodes. I think they go well, and we get a nice mix of experience levels with the technology, at least, even if we have, highly qualified people. So I'm going to shout out about that. Just email me, chuck@devchat.tv. I'm also working on pulling together a Python show, a machine learning show. So if you're interested in being on any of those, same deal. Cool. In fact, this episode may come out around the same time the machine learning show comes out. I'm going to go full on self-promoting since we're talking about podcast network and stuff like that. I've had a few people reach out to me and ask how they can donate to the shows. So I'm working on getting information up. I think if you go to devchat.tv/support, it'll tell you how you can send money over Venmo or PayPal or something like that. I've had a few people talk to me about Patreon, so we'll see if that works out, and Open Collective. So I'm kind of playing with the ideas there. The shows are ad supported, but if you've been listening to this show for a while, the ads have been, hey, go listen to one of the other devchat.tv shows, just because we're still getting established and we don't have that strong base that the advertisers like. And I'm a little bit choosy. If I don't like the tool, then I won't let them advertise. And that's just me. And maybe that's insane, but that's just the way I am. If I don't think it's going to help people, or I think it's a pain in the butt to use, then I'm going to tell them no. So it's been a little bit tricky to get the right kind of sponsor on. So if you want to help support this show or some of the other shows, I'd appreciate that as well. And then the last one is, I just kind of had a little bit of downtime over the weekend. Actually went and spent some time with a bunch of guys that I talk to every week and kind of live life with every week. We all live in different parts of the country, but we get on a call every week and chat. And that was so productive and so kind of healing. And so I'm going to pick that as well. And those are my picks.
Cool. Thank you, Chuck. Oleg, do you have a pick for the audience?
Well, actually, it's a good addition to the book you suggested, The Age of Spiritual Machines, Kurzweil. So you probably heard about that. I already read that already, and check it out. It's a very optimistic book about how intelligence develops. I suppose it continues very well. Sapien.
You said it. What's the name of it again? Sorry.
The Age of Spiritual Machines. And
the Age of Spiritual Machines.
I'll send the link.
Cool. Very nice. Yeah, Ray Kurzweil. Okay. Okay. I got you. Very nice.
Yeah, his stuff's always interesting. Sometimes I'm a little bit skeptical, but it's usually extremely well thought out. So I have to at least go, okay, why am I reacting to this? And
Yeah.
I think Fukuyama readings are also in the line with those authors we discussed. Some people may be interesting to check him out as well.
Yeah, very nice. Well, cool, guys. Thank you very much. And thank you for tuning in for another episode of Adventures in DevOps. Thank you.
Okay, thank you.
Yep. Everybody max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.